we are in engineering scales. How to construct an engineering scale, as we have discussed, right? So actual length or actual area or actual volume, we cannot directly represent on the paper, okay, on the drawing sheet. For that, what we are taking is we are taking suitable scale. Scale means scale may be reduction scale or enlarged scale or full sized scale. So as you said, okay, if I want to represent 10-kilometer road, so I need to go for a reduced scale, right? I need to reduce that particular length into some suitable length, like 1 centimeter, as you said, right? 1 centimeter is equal to 10 kilometer. So we are assuming like that. So that factor is known to be the representative fraction. Representative fraction. So all the maps like India map or Telangana map are drawn to a particular scaling factor, reduction factor. Okay, that reduction factor we call it as representative fraction. If it is a reduced scale, if the actual length to be reduced, then we use reduced representative fraction. Okay, suppose the original object is very small. If you want to enlarge its size, we will go for enlarged scaling factor. Okay, suppose if you don't want to reduce or enlarge particular object, for example, if you take a cell phone, right? Cell phone is having length some 5 inches. Okay, can you draw 5 inches line on the drawing sheet? You are using A2 size, right? Can you draw 5 centimeter or 5 inches length? Is it required to reduce that length or increase that length? Not required, right?
Yes.
That is called full sized scale. So that we call it as full size drawing, full size scale or full size drawing. Okay, suppose actual length is 10 kilometer. Can you draw 10 kilometer line on the drawing sheet?
No.
No. For
No,
that
sir.
we are taking the reduced scaling factor, like 1 is to 10, 1 is to 100. Have you seen it is representing like 1 is to 10, 1 is to 20? That means 1 by 20. Okay, that means we are reducing 20 times. If it is 1 is to 50, we are reducing the actual size for 50 times lesser. Okay, in this way, the concept is involved in the particular scales. There are basically two important scales, okay, or three important scales, like plane scale, diagonal scale, and vernier scale. Okay, so these three are important. However, vernier scale is not in your syllabus. Okay, only first two, that is plane scale and diagonal scale, are there in your GR20 regulations. Okay, so the problem will be like this: construct a scale of 1 is to 4 to show centimeters long enough to measure up to 5 decimeter. So I will explain one or two problems, then you can able to answer any other problems given. Okay, so listen one or two problems only clearly. Okay, then you can solve any number of problems on your own. So simple calculations are there. You need to calculate such a simple calculations, and you can now ready with the drawing the construction of any engineering scale. Okay, so I have explained, right, what is the importance of scales, right, to make up uh, uh, geometrical, okay, areas, okay, to represent large areas on a small paper, right? So we need to take all the scales. We construct as per the requirement. Okay, so nothing but we are designing a particular scale. Remember, in your mind, we are designing some scale, suitable scale. So here you can read the problem carefully. Say there is a relation between is asking centimeters and meters. So whenever I dictated one problem like this, you will have so many questions, right? What is a scale of 1 is to 4? What is asking 1 is to 4 is means what? So what is the centimeters, and what is the long enough measure up to 5 decimeters. So you must know the basic units conversion. Okay. So can you tell me 1 centimeter is equal to how many millimeters?
10 power minus 1.
10.
10.
Very good. Very good. But here there is no millimeters in the given problem. Is the relation between centimeters and decimeters only. Now tell me, 1 decimeter is equal to how many centimeters?
10.
10, sir.
10.
Okay. Okay. Now for that, you just note down somewhere the relation between so many other units. Generally, we come across in our particular uh, uh, in the practical problems or in our particular syllabus. Okay. Now, are you able to see some screen I am sharing? Okay. In Paint, I have opened one file. Can you see that? Are you able to see that? Hello?
Yes, sir, we can see.
Sir.
So if you want to know some relations, okay, please note down somewhere on your rough paper. Okay. Now, can some of you can you read what is there in the first line? 1 kilometer. Yeah, Shushmita, are you there?
One
Please
kilometer,
just read out.
1 kilometer is equals to 10 hectometers.
Very good. Next,
1 hectometer is equals to 10 decameters.
okay, 1 decameter,
1 decameter is equals to 10 meters.
10 meters. 1 meter,
1 meter is equals to 10 decimeters.
yeah, 10 decimeters. Yeah, next,
One
1 decimeter,
1 decimeter is equals to 10 centimeters.
very good. So 1 centimeter,
1 centimeter is equals to 10 millimeters.
very good. So remember, whenever we are given the relation, now identify which relation is given in the particular problem. 1 decimeter is equal to 10 centimeters, right? Yes or no? This is the relation given. Am I correct? Now, there are for measuring the length, not only these relations, sometimes 1 mile is equal to 8 furlongs, 8 furlong, 10 chains. Okay, one chain 10, 22 yards, 1 yard 3 feet, 1 foot 12 inches, 1 inch 2.54 centimeters or 25.4 millimeters. Okay, have you heard about miles, right?
Yes, sir.
Yeah. Have you heard about furlong?
No, sir.
No, sir.
These things generally civil engineering students will use chains. Okay. Okay, one chain is equal to 22 yards. Have you heard about yard?
Yes,
22
sir.
yards.
Yes.
So 22 yards. I think you are familiar with the 22 yards.
Cricket pitch.
Yeah, cricket pitch. Very good. So those who are interested in cricket, they can easily identify yards. That is the length of one chain. Okay. Civil engineering students generally use these furlong, miles, chains language. Okay. All are these are the units of length only. Okay. Maybe it is a metric system. It is some British system or something like that. Okay. So 1 yard is equal to again 3 feet. 1 foot 12 inches, 1 inch 2.54 centimeters. So you must know while construction of any engineering scale, the units are very important. Okay. So remember all these important units. Okay. Now I will go back to the problem. Construct a scale of 1:4 to show centimeters and long enough to measure up to 5 decimeters. Okay. I don't want to construct the scale beyond 5 centimeters. My requirement is only construct or design one scale which is capable of measuring up to 5 decimeters. Okay. Now, can anybody guess what is this ratio 1:4? Can anyone guess what is the scale of 1:4 means? I've already given some introduction, right? Can you guess now?
1 mm is equal to 4 centimeters.
Okay, okay. Actually, it is the ratio. There will be no units. In other words, you can say that uh, the drawing size we are assuming 1 unit, but actual there are 4 units length. Okay, or length or volume or area, whatever it may be. Actual object is 4 units. We are reduced to 1 unit. Am I clear? Can I explain once again? Actual, the road length is some 4 kilometer. I am assuming it is 1 centimeter on the drawing sheet. Something like that. Okay, that means drawing size is 1 unit, centimeter or whatever it may be, kilometer. You need to understand the numerator is the drawing size. Okay, the denominator is the original actual object size. That can be road or any land, okay, or any big water tanker, okay, size that can be represented. So this ratio, I call it as representative fraction, RF. Remember, can you repeat after me? RF, representative fraction. Yeah, I think you are not following. Are you there?
Yes,
RF.
sir.
Yes,
So what
sir.
is RF?
Representative fraction.
Very good. So here it is given directly in the problem. So drawing size by actual size is given directly. Otherwise, you note down the formula, which is equal to drawing size by actual size of the object. Okay, if nothing is given 1:4, at least they will give you the relation between actual size and drawing size. Simply you take the ratio, convert into the same units, you will get the uh, ratio like this. Okay, at the time you need to calculate. Otherwise, here in this problem, as given directly, he has given directly RF in the problem number 1. Maybe in the problem number 2, RF may not be given directly. So the representative fraction, note down, which is equal to the drawing length by or drawing size by. Why I'm calling size means always it is not necessarily length. There will be some area problems, land, agriculture land, so many other related to area problems. Okay, and sometimes the units may be volume. That means centimeter cube, meter cube, kilometer cube, like that. Okay, in case of water tanker, right? What is the size of the tanker? Okay, that you cannot measure in terms of area. In terms of volume, you need to measure. So that's why I'm telling. Note down, RF is equal to drawing size by actual size. So somewhere it is very important to write. It's very important. That's why I'm insisting on that. So I'm writing somewhere here. I think it is better. RF is equal to, I am taking the ratio drawing size divided by actual size of the object. Okay. But size can be length or area or volume. volume. So you remember, initially we are discussing RF in terms of length only. Okay. If what happens if the problem changes to area, you take the RF is equal to square root of drawing size by actual size. Remember, if the problem is area, okay, then RF equal to square root of drawing size by drawing size divided by actual size. So it takes more time if I think on the drawing whiteboard. Okay, please. I think, are you following?
Yes, sir.
So it's a calculation, simple calculation. Sometimes it is given in the problem. Otherwise, you need to take this ratio. If the problem is area, you can easily identify the problem. Okay, whether it's area problem or volume problem or length linear problem, you can easily identify. So what I'm saying is, if it's length problem, directly you take RF is equal to drawing length by actual length of the object. If it is an area problem, take square root of that formula, same formula. Okay. And if it's a volume problem, if it's a volume problem, what you have to take? RF is equal to cubic root. Okay, cube root. Then automatically you can calculate the representative fraction. Okay. Then I will go back to the problem. So he has given RF directly, you need not calculate. So after taking drawing size by actual size, you would get 1:4. So it is given in the problem itself. Now you need to design a scale. That scale length must be maximum of 5 decimeters. Okay. So you write down, this is also important, maximum length ml, I call it as ml, 5 decimeters. Okay. Now importantly, you need to draw one rectangular scale or rectangular box on the drawing sheet. So that must have some length. That is the designed scale length. Okay, length of the scale in centimeters. That is equal to RF multiplied by maximum length to be measured. Are you following? The length of the scale in centimeters is equal to RF multiplied by maximum length ml. Okay. Using this formula, you're supposed to calculate the length of the scale in centimeters. Now RF is equal to how much? 1:4, 1/4 multiplied by maximum length is how much? 5 decimeters. Now can you convert into centimeters? I require in centimeters, right? What is 1 decimeter? How many centimeters?
10.
10.
So can you calculate the ratio? What is the value you are getting? 1/4 into 5 into 10. What is this value? What is that value?
12.5.
12.5. So you take your need drafter, mark a distance of 12.5 on the, you draw one horizontal line. Okay. Now divide that into equal number of parts. How to divide equal number of parts? Because we require the maximum length of the scale to be measured is equal to only 5 decimeters, right? So highlight, remember, we need to divide only 5 equal parts because I require a scale. I wanted to design a scale maximum of 5 decimeters, right? So what I am going to do is that particular length of the scale, where what we have calculated 12.5, right? You divide that length into only 5 parts. Then tell me each part will be equal to, then what happens? If I divide this 5 decimeter scale, okay, into 5 equal parts, each part will be
1 decimeter.
1 decimeter.
1 decimeter. So that's why I am dividing this length of the scale 12.5, only 5 equal parts. So each part will be 1 decimeter. So now you follow the step-by-step procedure while drawing on the drawing sheet. First calculate RF, length of the scale, convert into centimeters. Now take your drafter, draw one line. What is that length of this line?
12.5 centimeters.
Yeah, now I will ask you one important question. This 12.5 centimeter represents, okay, exactly how many decimeters? How many decimeters?
1.2.
No, wrong.
5. 125.
5.
Not 5, not 125. The correct answer is no, 1.2 wrong. This 12.5 centimeter line represents how many decimeters I am asking. In the real practical problem, I am asking.
5.2.
No. So that is important here.
1.25 decimeter.
1.25, sir.
No, no.
5.
Yes, 5 is the correct one. Why? Because actually speaking, that 5 decimeter we are unable to draw on the drawing sheet. That 5 decimeter means 5 into 10 centimeter, 50 centimeter line. We are not able to draw on the drawing sheet. That's why 4 times we have reduced that particular length. That's why that RF factor is equal to 1:4. 4 times we have done reduction, right? So that's why we got only 12.5 centimeter line. If you multiply 12.5 into 4, how much you will get? 50. That means 5 decimeters. So understand the scaling concept very little bit typical, but if you understand, you can able to make up any problem. So we have calculated length of the scale because we have taken a representative fraction of 1:4 because we are unable to take that line as it is on the drawing sheet. Okay, we are unable to draw a 5 decimeter line directly on the drawing sheet. If you want to draw 5 decimeter line, you need to draw 5 into 1 decimeter, 10, right? 5 decimeter means 50 mm long line, 50 mm. Is it correct? Yeah. So I am unable to draw that line. That's why I have applied representative fraction of 1:4. So my line length becomes only, after calculating maximum length multiplied by representative fraction, I got only 12.5 centimeter. Understood? So, but since it is 12.5 centimeter, don't think it is only 1.25 decimeter. Okay. Actually, it is representing 5 decimeters. Okay. In this particular 12.5 centimeter line, there are 5 decimeters. Forget about this 12.5 centimeter, what we have calculated. But we go back and remember, after applying that reduction factor, representative fraction, okay, you got this particular length. Okay, even though it is 12.5, neglect it. But what the meaning behind is, this line represents, for me, it is 5 decimeters. Understood the concept? Can I proceed with? Can I proceed with?
Yes, sir.
Okay. Now, if I divide this into n number of equal parts, tell me how many number of equal parts I have to do.
5.
Okay, why 5? Why only 5? Can you give me explanation?
Because 5 decimeters, now, so we have to divide it into
1:4, no, sir. Sum is 5.
No. Oh, don't bring such concepts. Okay, those are wrong concepts. Okay, don't add 1 plus 4, 5. Okay, not like that. So what I said, this represents 5 decimeter. Okay, in your mind there are 5 decimeter. Okay, whenever you see this line, you need to think It is the maximum length to be measured, which is capable of measuring 5 decimeters. Okay, if I divide with 5 equal parts, then each part will be, can you please tell me? 5 decimeter, if you divide with 5 equal parts, each part will be,
One decimeter.
yes. For that reason, conveniently, okay, conveniently we are dividing 5 equal parts only. For example, maximum length measured is equal to 6 decimeter in the given in the problem. Now tell me how many parts I have to do.
Sorry, sir. What is the maximum length?
If maximum length to be measured is equal to 6 decimeter, for example, 6
1.2, sir.
decimeter.
6 parts.
How many parts I have to do? 6 parts. Okay. According to the problem, you check the problem. So maximum length is the criteria. According to the maximum length to be measured, so that many number of parts you need to take for convenience. Okay. For example, this represents 5 decimeter, right? In our problem, if suppose 6 equal parts, what happens? Each part will be, again you will get a confusion, right? So conveniently we need to take. So this line represents 5 decimeter. If I divide into 5 equal parts, I will get 5 equal parts, which each part will be 1 decimeter. Now are you following? 1 decimeter, right? Can I proceed?
Yes.
Now, after drawing this 12.5 centimeter long line, divide this into 5 equal parts. You know the procedure, right? You draw any angular line, draw that 5 equal arcs on that. Last arc you need to join to the other end of the line. Now match your mini drafter scale parallel to this longer line, longer edge you can match, and tight the mini drafter knob. Okay. And the mini drafter frame you need to fix to the drawing board at the top left corner. That frame you have to fix somewhere here, and now then you can move the drafter anywhere on the drawing sheet. You are free to move the drafter anywhere on the drawing sheet. Okay, then and importantly, you just fix the drawing sheet right hand side down corner, somewhere down corner. Okay, suppose you are seeing my screen, right? I am showing you this is the down corner, right hand side down corner. You need to fix the drawing sheet, and left hand side top left corner. Okay, top left corner you need to fix somewhere here the mini drafter frame. Now you can move the mini drafter 360 degrees or completely around the drawing sheet. Now after joining this last arc to this end of the other end of the line, then match your mini drafter scale to that line and tight the mini drafter knob gently. Okay, don't tight hard. Okay, then that drafter may get damaged. Okay, then move the drafter scale parallel to that line. You would get 5 equal parts. Okay, like that you need to draw parallel lines parallel to this particular line already you have drawn. Now, so in order to show it is some type of scale, simply you draw one rectangular box. So the height of that box you can take any value. There is no importance. You can take 2 centimeter or 3 centimeter for drawing this height. Okay, no importance given to that. So length is 12.5 only. You need not change it, and you construct a rectangular box. So automatically by line division method I have done 5 equal parts. You draw these 5 parts also, and number these parts. Okay, now here while putting the numbers for the parts, you leave first part. Okay, don't give number starting from here. Give the first part. After first part, you start 0 here, 1, 2, 3, 4. That means 0 decimeter, 1 decimeter, 2 decimeter, 3 decimeter, 4 decimeters. And below this, I have drawn so many horizontal lines for writing something like decimeters, RF factor, okay, and centimeters. Okay, I will tell you later why I have drawn all horizontal lines here. Okay, number system is important. Don't start your numbering system 0 here, okay? Leave one part, then you give the number system 0, 1, 2, 3, 4. And now, see, in this constructed rectangular box, how many decimeters are there total? How many decimeters?
5 decimeters.
So after leaving 1 decimeter, so I am taking 0 decimeter, 1 decimeter. That means to the right hand side of 0, how many decimeters are there?
4.
4, sir.
Very good. To the left hand side of 0 mark, how many decimeters are there?
1.
1.
1. So total 5. So my next step is, because we need to construct this scale, we need to design this scale so that we need to relate main unit and its subunit. Main unit is the decimeter and its subunit is centimeter, right? We have already seen. What is the relation? Centimeters and decimeters, 10. This is the relation. But if you take chain and yards, what is the relation? 22, right? If you take mile and furlong, what is the relation? 1 mile is equal to 8 furlongs. 8 is the relation. Okay. For example, you are given kilometer and hectometer. 1 kilometer, how many hectometers? 10. So that's why it is very important. For example, in the next problem, you are given yard and relation between yard and feet. 1 yard is equal to how many feet?
3.
3.
Now, accordingly, you need to divide this particular first part. Okay. Now, as you said, in the first part, 1 decimeter is there. You need to divide 1 decimeter is equal to how many centimeters? 1 decimeter is equal to how many centimeters?
10 centimeters.
So divide this first box. So small box is there right here. We need to divide this into equal number of parts. That equal number of parts depends on the unit and subunit relation. Okay, 1 decimeter, 10 centimeters, right? So again, by doing line division method, apply line division method, you draw one angular line. Okay, take this edge. Take this edge. This is the 1 decimeter box, right? Now, yeah, you draw one line like this initially, angular line, any angle, right? I told you 0 to 90 degrees you can use any angle. And how many arcs I have to draw on this line? How many arcs?
10.
10. Why only 10?
Divide into 10. 1 decimeter is equal to 10 centimeters.
10 centimeters. Very good. Suppose the problem is something like yards and feet. So how many arcs I need to do here?
3.
3, because 1 yard is equal to only 3 feet. So in this way, the problem changes. Otherwise, the procedure is same. Okay. Here, why we need to take only 5 parts? Because there is 5 decimeter in the problem. Only 5 parts I have taken. 1 decimeter to the left hand side. That's why I kept 0 here, leaving 1 decimeter left hand side. Because further we need to divide that part. Okay. So 1 decimeter is equal to 10 centimeter. I have taken 10 equal arcs. Then again, using first you join the last arc to the other end of the line. Okay. Draw parallel lines with help of mini drafter from different arcs. Then you can drop vertical lines, okay, with the help of mini drafter again. While see here you have drawn with the help of mini drafter so many parallel lines. Simply just lose the mini drafter knob, then match your mini drafter scale to the horizontal lines already you have drawn, then tighten the knob. Automatically the other scale you can use for drawing vertical lines. Okay, so complete all these vertical lines up to the center. Also you can extend, or you can draw full along. You can extend these lines up to you complete. I have shown you only half of that box. Okay, you can extend further, no issue. Okay, because we are designing, right? We are designing so that the scale is looking good. Okay, it is having good appearance. And now I will ask a simple question. So we have divided 10 equal parts. Okay, 10 equal parts. Now in that I will call them as some division, 10 equal divisions, right? Each division represents what? Each subdivision
0.1
represents what?
decimeter. 0.1 decimeter.
1 centimeter.
0. centimeter, sorry.
You say that 1 centimeter, that is sufficient. Okay, so 10 centimeters, it becomes 1 decimeter. So you need to use this scale. Okay, can you mark on the scale 3 decimeters and 7 centimeter? Can you mark using the scale? Can you mark 3 centimeter and 7 decimeter if it is the question given in the problem? Okay, can you mark the length? Can you mark? Is my question is clear? So what you have to do is 3 centimeter, 7 centimeter you need to mark. So to the right hand side, take the main unit 3 decimeter. You draw one vertical line here because this is the 3 decimeter line. And where is the centimeter? To the left hand side of 0, right? So you number it as 1, 2, 3, 4, 5. I have shown you 5 and 10 only. In between I did not show any values. Here you can start from 0, number it from right to left. 1, 2, 3, 4, 5 centimeter, 6 centimeter, 7, 8, 9, and lastly it is 10. That is indirectly it is 1 decimeter. Now can you mark 3, 7? Say yes or no.
Yes.
Yeah, you draw one vertical line from 3, left hand side 7. After 5, 6, 7, you draw one vertical line again. In between, you draw one horizontal line. Show it as 3 decimeter and 7 centimeter. Okay, in that way you can use that scale for measuring any distance. But this scale is capable of measuring only 5 decimeters only. In between 5 decimeter, you can mark any distance. Beyond 5 decimeter, if I ask you to mark 6.7, it is not possible. Okay, it is not possible. So that is the maximum length. With the help of this particular scale, we can measure maximum length 5 decimeters only. Okay, so can you able to draw? So it's very simple diagram, right? Compared to the earlier problems like conic sections and cycloids, it is easy, right? Yes or no?
Yes.
Simply, you need to draw one rectangular box, divide that into n number of equal parts. Again, first part you need to subdivide n number of equal parts, right? Here, very important is just you draw 5 mm lines. I have shown you here 5 mm lines. So while putting the 1, 2, 3s also, I have mentioned, I have given some horizontal 5 mm lines. In between 5 mm lines, you need to write the letters or numbers. So in general, it is not required because it is taking more time. So at least for mentioning RF, decimeter and centimeter, draw two 5 mm lines, two 5 mm lines. In between 5 mm lines, At the center, below the figure, you write RF is equal to 1:4. This is compulsory. If you did not mention this RF value, there is no use of this scale. Nobody can understand for what purpose it should be used. Okay. So right hand side of 0 mark, somewhere you have to write DM. You can write full DC meters. Left hand side of this 0 mark, you can write in full centimeters. Don't write CM, DM. Okay. Simply write in capital letters. Completely you write centimeters. RF, you can use RF because it is having some meaning, and decimeter you can write. So apart from that, you need not write anything on the drawing sheet. And remember, this rectangular box inside 4 vertical lines, and these sublines you can use HB pencil. Other lines must be 2H pencil only. I hope I have cleared all the necessary steps to be followed, instructions to be followed, okay, while completing this plane scale. So I think we have very less time. We will continue in the next class. We will take one more example of plane scale, okay. Then we will have one assignment problem on that, okay. Then thereafter we will practice diagonal scale 1, 2. Then I will give you one assignment problem from diagonal scale. So any doubts you can have for 1 or 2 minutes?
Sir,
Yeah.
should we draw that scale on drawing sheet, sir?